Welcome all. This is the first tech talk from IEEE ComSoc Bangalore Chapter. Um, Essentially, IEEE ComSoc Bangalore Chapter has many events. We have, if you look at the events that we did last year, you will find not only a lot of seminars related to 5G, data integrity, AI, ML, but also we did a lot of events in terms of student internship, and then we also did a lot of events related to um knowing what the ComSoc does, what kind of advantages ComSoc provides in terms of membership to students, to academia. We also had a couple of workshops with some of the top industry folks, like the Nokia workshop and then an open source workshop. And it will be our endeavor to continue that this year as well. And this year we have a lot more coming up in terms of the world moving towards 6G, and also you can see that there is a lot of work which is going on in ITU, and people, researchers, people who do standardization, they are all leaning towards knowing more and starting their activities. So today also, the theme of our talk is along the same lines, and I would like our vice chair, Sujata madam, to kindly introduce the speaker.
Thank you, Anindya sir. I hope I'm audible.
Yes, Sujata madam.
Okay. It's really a pleasure for me to introduce Mr. Pranav Jha. Mr. Pranav Jha works with IIT Bombay, Mumbai, as a senior scientist at IIT Bombay. His current research interest lies in broadcast broadband convergence, rural broadband communication, and network architecture for 5G and beyond. He is an active participant in the development of telecom standards and contributes to IEEE, 3GPP, TSDSI, and ITU standardization efforts. He also chairs two IEEE working groups, IEEE P2030.1 and IEEE P2061. Thank you, Pranav Jha, for accepting our ComSoc invitation to deliver the talk on Towards 6G, System Architecture, Learnings from IEEE 1930.1 and IEEE P2061. Over to you, Mr. Pranav Jha. Thank you.
Yeah, thank you. Thank you very much for giving me the opportunity to talk about these two standards, IEEE 1930.1 and IEEE P2061 today. And I hope I will be able to, provide some insights into these two standards, what ideas have been proposed, and how these ideas may have the potential to, provide some interesting thoughts for the upcoming 6G system architecture. So, yeah, just a minute. Okay, sorry. Yeah, so the first of all, disclaimer, this presentation neither reflects the official position of IEEE nor that of the working groups vis-a-vis the two standards. It only captures my understanding of these standards. So that's actually very important to highlight. Okay, now let us go to the agenda for today. So I will initially talk about the status of the standards. I mean, what has happened so far. Then a brief introduction on 3GPP 5G system architecture and some of the issues that led to the standardization of IEEE 1930.1 and to some extent to 2061. And then I will dwell on the 1930.1, the key concepts behind it, the advantages of those concepts, and how it can be integrated with the 3GPP system, especially the 5GS and beyond. And then I would also, if I have time, we talk about P2061, a Frugal 5G network as it is called, and then summarize it in terms of how some of these concepts may lead to 6G system architecture. This is the brief status of 1930.1. It's a recommended practice in IEEE standards terminology. So maybe you can read about it. What is a standard and what's a recommended practice? And the goal of this standard was to define an SDN-based architecture for multi-RAT wireless access network, and to define an SDN middleware which facilitates unified control and management of this multi-RAT wireless access network. It was approved as a new standard by IEEE SA on 16th June 2022, and it was published on 2nd September 2022. So it is available for download from the IEEE website. 2061 is also, the working group is called Frugal 5G Networks. So the goal of this standard project, P2061. So you might have noticed that I'm talking about P2061, whereas I talked about, in the case of 1930.1, I did not put a P because 1930.1 is an approved standard, whereas P2061 is not yet approved. So that is what I know. The standard draft is ready, and we have started the process of approval. And we are in the working group balloting stage, which is the first step towards the approval of the standard. So we hope that it will get approval towards the end of this year, and it will be published as a standard at the end of the year 2023. Now, the goal of this standard project is to define an architecture for low mobility, energy efficient network for affordable broadband access. So it essentially, is a standard for enabling affordable rural broadband communication. But we will see that some of the ideas which have been proposed here may help us in designing the 6G system architecture as well. So the standard aims to define a wireless access network. It also has a wireless mid-haul, we call it middle mile network. And then there is a control architecture for the access network as well as this middle mile network. The goal of the standard is not to develop any new wireless access technologies, but to identify relevant existing technologies and bring them together within an architectural framework to enable affordable broadband access in rural areas. So that's the goal of the standard project. Okay. So now I will go over to the a brief discussion on 3GPP 5G system architecture. So if we look at this, so a key aspect of the 3GPP 5G system, which I will talk multiple times in this presentation today, is that it proposes a converged core which can talk to multiple different radio access technologies. So in the access network, so you can have a 5G new radio based access. You can also have LTE based radio access. You can also have WLAN, non 3GPP access technologies, and they all can talk to a converged 5G core. So that's an important feature of the 5G system architecture. And this converged core talks to these different access technologies through a standard interface. The interface remains the same irrespective of the access technology in use. So the same control plane interface called N2 interface is used. Whether a GNB talks to an AMF or a Wi-Fi based access through functions like N3IWF talk to AMF or the core network. Similarly, for the user plane or the data plane also, the same interface is used between RAN and core network, irrespective of the access technology being used. But the RAN itself is fragmented in the sense that they do not really typically talk to each other. There is communication between the same access technologies, like 5G GNB talks to other 5G GNB. There is an XN interface, but the 5G GNB does not really talk to Wi-Fi access technology uh, access nodes. So that is, one of the other aspects that we want to highlight here. Then we also see that even though there are different access technologies, but there is a tight coupling between the functionality used to talk to the core network and talking to the access network. So you can use different access technologies, but you cannot really use a different core. So the core is 5G core. So it doesn't really allow you to, abstract the core out and place a different core here with a different access, different, features and capabilities. So that is something that, we want to highlight. And so the question that you can ask is that, can I connect a 5G RAN to 4G core? If you look at the core, there is not much difference between what they do. There are a lot of different elements in the 5G core with respect to 4G core, but ultimately the functionality which is provided in 4G core and 5G core are not much different from each other. So can I use 5G RAN with 4G core? So that no, so that's not possible. So, that is, or maybe tomorrow, let us say I have 6G RAN coming up, and then can I connect it to 5G core? So no. And, one of the impacts of that was that if you know about the non-standalone architecture where a 5G GNP has been connected to 4G core, but through a, special mechanism. So the point is that this was required because there is a tight coupling between the core and the RAN. And the other question that we would like to understand and ask is that, is core network really necessary? I mean, is it necessary in all scenarios? And is it possible to connect RAN directly to internet or to data networks? So, bypassing the core. So some of these are some of the things that, are not possible today. The core is a mandatory aspect of the cellular network, and you have to go via the core. And in the case of 5G system, the 5G core. Now, so now let us go to some of the aspects, additional aspects of the 5G system. So here we have shown a feature called dual connectivity. Now it's a very interesting feature where user equipment or a mobile device can connect to two base stations simultaneously. Now, the base stations can belong to the same technology like 5G NR, and they can be two GNBs, or it can be a GNB and an LTE node B, or it can also be LTE node B and Wi-Fi access point, and it can also be 5G GNB and new radio-based base station and a Wi-Fi access point. So there are multiple possibilities which are there as far as the dual connectivity is concerned. But the mechanism, ultimately the feature essentially enables connectivity to two base stations, concurrent connectivity to two base stations for the same UE. But how this is enabled is actually quite different. So, the mechanism for enabling dual connectivity with two GNBs and between a GNB and or a GNB and an ENB or a GNB and Wi-Fi are quite different from each other. In some cases, there is a coordination between the RAN nodes. In some cases, the multi-connectivity or dual connectivity happens through a coordination in the core. So What we are trying to highlight is that even though the feature is dual connectivity, but it is implemented in different ways, depending on the radio access technology being used. Similarly, I would like to talk about another feature, say load balancing in access network. So if you want to, do a load balancing through different radio access nodes, especially, if you have, a lot of small cells and macro cells and so on, and different access technologies like Wi-Fi, and Wi-Fi is a very important access technology. So we see it everywhere being deployed. So if you want to do load balancing across GNP and Wi-Fi, it is actually not possible. So there are some offload mechanisms, which are legacy offload mechanisms coming from the previous generations. And there is some mechanism which is available in the 5G system, which is enabled through the core. But there is no RAN level coordination between a GNB and a Wi-Fi access point to do the load balancing. So these are some of the aspects of 5G system where we hello, yeah, it seems sharing stopped somehow. Just a minute.
Can you
Okay.
reshare again? Should not.
Yeah, I will try.
I don't know why. I think it went to someone else. Yeah.
Yeah, it looks like okay.
I would
Now
request the
is it
audience not to kindly share anything. I think somebody was trying to share something, looks like.
okay? Okay. So is it visible now? My
Yes, yes,
slides?
yes.
Okay. So what we are trying to highlight here is that if you look at, say, these two features, these are just two examples. It is not that, these are the only two features that we want to talk about. But, you will find that because of this fragmented RAN, there are complexities in the radio access network. And especially these complexities are coming when you have multiple access technologies present, and then you may not have a very optimal resource utilization. You may not be able to do load balancing across RATs, and in some cases you may be able to do it, but not in a very efficient and optimal way. So these are some of the things that are crucial aspects of the 5G system. Now, looking at these, some of the questions that actually drove the development of the two standards, 1930.1 and 2061, have been highlighted here. So, in the context of how the system architecture should evolve beyond 5G. Now, these are not really, a list of all exhaustive points. There are many other aspects that will come into picture and that we already are also looking at, and we are also wondering about some of the other aspects that may play a very important role in 6G system architecture. But here, what I have highlighted is the aspects which were considered in 1930.1. And when the standard was coming up with a system architecture for the multi-rat RAN. So one of the aspects was that can we have a more scalable architecture with further disaggregation of data plane especially, and control plane also, and with more modular and reusable network functions. So that was one question which was asked as part of the 1930.1, and it is actually one of the key aspects of the standard. Then the other question was that should we have a unified multi-rat RAN? I mean, unified, which may lead to unified treatment of features like dual connectivity. And then, another aspect which was discussed is that should we use SDN, where we separate the control plane and data plane with a logically centralized control plane. Maybe that will help us in features like dual connectivity, where we have a centralized entity in RAN which decides, the dual connectivity, and and also features like load balancing, and tries to take the decision in the through logic at a centralized controller. And then a very important aspect was that are there enough interesting abstractions, especially available for the virtualization of RAN? So there is a much talked about feature called network slicing, and based on whatever limited knowledge we have, we think that it hasn't really been implemented so much in RAN, especially in RAN. And we think that, or the 1930.1 group thought that maybe one of the key reasons is that there are not good enough abstractions for implementing network slicing. So you have network slicing implemented on GNBDUs, and they are specified as a list of parameters as which network slices are there. But it is not really a very neat and nice implementation, that because the interface doesn't really lead to an abstract idea of virtual or resources in RAN. And that is where probably this feature hasn't really been implemented so much. That's our understanding, obviously. So maybe I'm wrong also, but that's the thing that P1930.1. Now, this second slide basically talks about the points that were considered as part of 2061. So 2061, as I mentioned, is essentially about enabling rural broadband access and developing architecture for rural broadband access, affordable rural broadband access rather. But some of the aspects which were considered here was, they arose in the context of rural broadband connectivity, but an important aspect that rose there was that can we bypass core for some users? I mean, do we need to use the core network in all scenarios? And one of the so the point that was discussed is that why do we have core network in cellular network, cellular systems? So essentially, the core network came into existence because of the mobility. So when the cellular systems were designed, so they were basically catering to mobile users, the users who were moving. And they were not really designed for stationary users. But now, when the time, as the time evolves, and as we see that the cellular or mobile systems are becoming the de facto connectivity mechanism. So they are the essentially the connectivity scheme or method or mechanism or system which is used by everybody. Now, it is not that all these users are always mobile. A lot of them, or a large percentage of them, are actually stationary, and many of the, say, machine type communication, or many of the machines or IoT devices, they may never actually move. So there are a large percentage of users which are stationary. So that actually, and when we analyze the rural connectivity requirements, we also realize that a large percentage of user may not really be moving most of the time. So do we really need the core network for such users? So can we have a mechanism to bypass the core? So that was the question that was asked by P2061. Then the other question, which I dwelt on earlier, is that can we decouple RAN from core? So can we make the core as an overlay thing for communication? So these two, actually, if you look at it, these two aspects are related to each other in a way. But decoupling, is essentially means that if we decouple it, then we can use any core with any RAN. If tomorrow a new core is developed, fine. If it is not developed, we can have a 6G RAN talking to 5G core. So no need for developing a new core altogether. And then you can have flexibility in deployments. The other aspect is that you can have a simpler core in that case. Some the essential functionality which the core does today, like authentication and all that, some of them can, obviously with sufficient security and all that, can be moved to RAN, and then core can become much simpler. So so these are some of the questions that were considered by as part of the P2061 deliberations. So these are the things that I will talk today. Okay, so now let me go over to 1930.1. Okay, so how much? Yeah, spent around 20 minutes. Okay, so I will briefly touch upon the idea of SDN. So SDN is a network organization principle where network is separated into two sets of functions, forwarding plane functions, which are responsible for data forwarding, and they can also be called data plane or user plane, and the control functions which control these forwarding plane functions. So they are basically responsible for setting up the data path. So they guide the data plane to how they should forward and a particular packet. So that is decided by the control plane, and that is communicated by the control plane to the data plane, so that data plane or forwarding plane can forward the packets appropriately. Now, the control plane is typically centralized. So you have, a function which can manage a large number of data plane nodes. And data plane or forwarding plane essentially is distributed. And that is basically the basic nature of forwarding plane. So you can't really do anything about it. Now, an important aspect of this separation is that you have a standardized interface between control plane and data plane. So in the communication networks, the internet kind of network or fixed line network, there is a very well known protocol called OpenFlow, which has been in use, and there are some additional protocols also. So those are that is a standard protocol used between the control plane and the user plane or data plane. Now, what does SDN enable? So a key feature that we think probably is very interesting is the virtualization of the data plane. So because of a standard protocol, which can give an abstract view of the underlying network, you can have a virtualization of the forwarding plane. And that is what that is what something attracted us to the 1930.1 towards the SDN technology or SDN principles. And then there are some additional advantages like improved utilization of network resources, and via a unified global view of the network, you have a network which can be programmed from the control plane, in the sense that the control plane can dynamically change how the packets will be flown and will be flowing through the data plane or the forwarding plane, and so in a kind of programmable network. And it brings cost effectiveness. You have data planes separately developed and control planes separately developed, and you can put some of these things as a simpler or modular functions. So that probably can bring cost effectiveness and so on. So now so that was one thing, and I will explain how and when the SDN has been used here. Now, one of the questions that, if you remember, I talked about is that can we have a scalable architecture for a radio access network? So, considering this, these are, so one of the key points that the 1930.1 realized is that if you have any RAN, mostly they perform similar functions. So you have radio TX-RX, and then you have PHY and MAC layers. Obviously, not it is not that the PHY and MAC layers are exactly the same. Obviously, they are different across different technologies, but that is something which you see almost everywhere. And then you have link adaptation like RLC or link control. It can be also called link control layer. So you have link control. You also have security as a very important feature of the radio access network. So you might need to encrypt, or you might need to and then you have optimization functions also. So you may like to optimize the data flow going over the wireless network to reduce the bits which are being exchanged over the wireless medium. And then, in the cellular scenario, you may have interworking with the core. So these are some of the functionality which is common across. So if we look at the 5G system, you see that all these functions are present in the GNB or the 5G new radio-based radio access network, and they are also present in Wi-Fi. They are also present in LTE Node B, and it is possible that if we can disaggregate RAN along these simpler functions, and maybe they will help us. That will help us in unified treatment of RANs. So that is one aspect of this. Now, if you look at this, so this was one of the key things which were put forward as part of the 1930.1 proposal, that you disaggregate data plane for multi-rat RAN, and through disaggregation you unify it. So if you see here, so it has been shown that you can have modular data plane functions, and you have a medium access control function, which basically includes MAC and lower layers, and it can be it is called BS in the 1930.1 terminology. And then you have security, you have optimization, you have RAN adaptation, which is basically link control, and ARQ and interworking function, which talks to the core. Now, the RAN can be disaggregated and split into smaller modular functions. So irrespective of which technology is used, it can be done that way. And then some of these functions can be used commonly across access. So if you see, the security can be common, whether it is Wi-Fi or whether it is 5G NR or whether it is LTE Node B. Now, today it is not the case, but it can definitely be done. And it has also been experimented in some way in different configurations, even in the LTE 3GPP networks. So if you know about LTE WLAN aggregation, you might realize that the same security PDCP has been used over both Wi-Fi and LTE radio. So it is possible to have common functions across RATs, and you can utilize those common functions. So so this picture is a simplified representation of this. Now you will find that there are three layers essentially here. So one is that RAN disaggregated data plane. Then on top of it, there is this SDN middleware. So you have this middleware, which I will talk in more detail later on, which actually provides an abstract view of the data plane to the control plane. So this middleware essentially unifies the diverse RAT-based data plane. So this, so it is it actually treats the underlying this multi-RAT access network, and it takes a virtual view of this and presents a similar view for all the RATs to the controller, so that the controller doesn't really worry too much about the RAT or radio access technologies based differences. It treats a base station as a MAC-PHY functionality, and it just directs a flow through that, data flow through that. So the controller, which is the control plane, or the third layer, which is the highest layer in this hierarchy of 90 in this list, in the 1930.1 architecture, this control plane has an abstract view of underlying RAT, and it doesn't really need to look at the details of each of these RATs. So that is what is hidden by the SDN middle. I'll explain it further when we go forward. Now, here, so this SDN middleware is essentially a layer between the control plane and the data plane, and it presents an abstract information model of the data plane through virtual entities. Now, these virtual entities are essentially data models. They don't really, typically, they don't have processing functionality, but the standard allows for them to have some processing as well. So it doesn't forbid any such thing. It says that, yeah, if you want to have processing functionality as part of these virtual entities, you can very well have it. But essentially, they are abstractions over the underlying data plane. So you have these virtual entities like VBS and VADPPF and VSF and optimization. For the sake of simplicity, we have shown 3 different VBS for Wi-Fi, LTE, and NR, but that may not be necessary. So depending on how the abstraction has been done or developed, it can be done. And then you have this SDN middleware is essentially orchestrated by an orchestrator over the data plane. So this virtual abstraction is created by this orchestrator. Now we must understand that there is no NFV here in terms of these virtual functions are not NFV based functions. They are just data models. So this VSF is just a data model which can be used by the control plane to configure this, which will ultimately translate to configuration of the actual SF in the underlying data plane. But the VSF does not really, have an NFV-based virtualization. So that is what we must keep in mind. So here the RAN is virtualized using the SDN principles and not really NFV principles. So you can always use NFV in data plane. You can use these optimization functions and network functions running on COTS platforms and all that. So these interworking functions or optimization functions and security, how they are implemented is up to the implementer. But for the middleware, these virtual entities are not really the NFV functions. So that is what I want to highlight. And then, so this basically presents a view of how this 1930 looks at it. So you have a unified multi-rat RAN where you have disaggregated data plane access points, base stations, interworking functions. And there is an orchestration functionality which orchestrates an SDN middleware on top of it. The SDN middleware provides an abstract information of model of underlying RAN through virtual entities. And then there is a multi-rat SDN controller which controls and manages the access network. And essentially, you have this multi-rat RAN which talks to the core network with a unified interface or unified interworking function. You don't really need different interworking functions to talk to the core, even though the rats are, there are multiple rats present here. So I'll show that again later on. How does it look like? So the SDN middleware has 2 interfaces, one towards the the controller, which is called the northbound interface, and one towards the data plane, which is called the southbound interface. So I'll skip this because this may take more time, and I think we are already, it is 2:10. But as I know, so earlier, as I said, that it is possible to have these virtual entities also have some functionality. So it is not that these virtual entities, which are part of the SDN middleware, they do not have any functionality. They may have, and the standard allows it, and that is what has been mentioned here. But typically, they are essentially the data models or the information model of the underlying actual network functions. Now, we'll look at some of the advantages that 1930.1 may bring. So, we talked about dual connectivity. Now, if we have a disaggregated RAN with the different data plane functions, so we can see that the dual connectivity implementation becomes quite simple. So you can have a single interworking function, as has been shown on the right-hand side, taking traffic from the core network. And a UE may be connected to 2 different base stations. So there can be a UE connected to 5G NR base station and a Wi-Fi base station. But the traffic from the core may come from the same interworking, via the same interworking function. It may go through the same security function and optimization function. But at the end of, after that, maybe it will use a different adaptation, like you may have a different RLC layer for LTE 5G NR, and you may not have any RLC in the case of Wi-Fi. And then the MAC and PHY layers will be different, obviously, for Wi-Fi and 5G NR. But as far as the controller is concerned, it can very well set up this path dual for the flows through these functions, where some functions are common and some functions are separate. So this becomes quite easy because the controller can just decide which functions to use, and depending on it will also look at may look at the load, and you may have multiple instances of these functions in the RAN, optimization function or interworking function or security function and so on. And depending on the load and so on, you can decide. But this control is completely with this unified multi-RAT controller, which is sitting on top, and this feature becomes much simpler to implement. Then, the load balancing is also much easier because you have a view of all the underlying functions and their loads. And then the controller can decide which function to use. Obviously, the radio unit will be decided by the UE normally. The UE only connects to which radio, but beyond that, which disaggregated, because you have disaggregated all the functions, so you can decide which optimization function to use, and you can have different instances and so on. And then, it becomes much easier to do load balancing. You can also do a handover of a flow from one radio's unit to another radio unit once the UE has connected. So you can do radio level load balancing as well by the controller. So, and then the third aspect which I would like to talk about is that because you have these virtual entities, so you can actually organize them in different, you can create multiple virtual entities which are responsible for different parts of the underlying data plane. And through this, different set of virtual entities, these different set of virtual entities can be placed into different logical networks or network slices. And it may be actually much easier to implement the network slice feature in this 1930.1 RAN. So I will talk about this again in the next slide, where I talk about how you can integrate it with 5G system, and then how does it look like. So a little more detail on that. So we'll come to that. Yeah. Okay. So now this is a very important slide to understand how 1930.1 can be integrated with the 5G 3GPP 5G system. Now, we talked about this earlier, that the 5G system has a converged core, whereas in the radio access network, you have different possibilities of different access technologies. So here I have shown three radio nodes. One is the WLAN AP, which is a Wi-Fi, can be Wi-Fi based, and there are two GNBs. So GNBs are called 3GPP access, and WLAN APs are called non-3GPP access. So for the WLAN, you need an N3 IWF function. There is another function also for trusted WLAN. So I have not shown all the features, and it is not really important to understand the concept. So, and then through this N3 IWF, you have this N2, N3 interfaces going to the core. Similarly, from the GNB also, you have N2, N3 interfaces going to the core. And 3GPP allows 3GPP access technologies as well as non-3GPP. Now, how do you, if you have a multi-RAT RAN, how do you, do it? So this is, a way of doing it. You can integrate multiple RATs here and within one controller. So you have multiple GNPs and WLAN APs, but then they talk to a single interworking function. And through that interworking, they go to the core. So, if you look at the previous figure, we had two GNBs and one WLAN AP. Now, one GNB and one WLAN AP has been collapsed in one multi-RAT RAN kind of, entity, a unified multi-RAT RAN. And this whole thing actually can be integrated as a non-3GPP access to 5G core without any impact on the 5G system. So the other GNBs can exist if they are not integrated within this unified multi-RAT RAN because of the, say, distance or location or whatever. Because a unified controller of RAN cannot really control all the GNBs in. So you will need to have multiple controllers and so on. But you can, so whichever, the radio access units and other disaggregated functions that we talked about are under one unified RAN controller, this whole thing can actually talk to 5G core as a non-3GPP access, even though the actual access technology being used on some of these are 3GPP access technologies. But what we are trying to say here is that the integration with the 5G system is actually quite straightforward. Now, some of the aspects that need to be studied here, which haven't been studied in 1930.1, is mobility and the impact on UE. But I have just tried to highlight the mobility between these two, say the GNB, which is shown below, and the unified multi-rat RAN, actually can be done through the existing procedures, and those are covered as PDU session handover. So that's one solution of that. So, but since you are doing this unified multi-rat RAN, so there may be some impact on the UE as well. So that is something which needs to be studied. And but we don't see a lot of impact. It is mostly some organization and reorganization of some protocol layers and functionality. That's about it. Okay, so now this is a more accurate picture. How does it look like? So you have this unified multi-rat RAN, which may have different access technologies. I hope, okay, 10 minutes. I'll try to wrap up in 10 minutes. So a unified multi-rat RAN, which may have different access nodes like LTE 5GNR node and 5GNR node, LTE node, WLAN node, and so on. And then all of them are virtualized through an SDN middleware, and they all are under one multi-rat SDN controller. And then you can have an interworking for user plane or data plane. It is not necessary that you have one single interworking for. You may have multiple interworking functions with different IP addresses and so on. And then those interworking IWF UP at the bottom right-hand side actually talks to the UPF. So all the data from UPF may come to this IWF irrespective of the actual access being used on with the UE. Similarly, for the control plane, you may have an interworking shown at the top right-hand corner, which will have the NGAP layer and so on, which will talk to the core for the N2 interface, and then that will talk to the multi-rat SDN controller and provide the inputs coming from the core for the control communication, and that can be utilized by the the controller to configure the data plane. So this is a more detailed view of how it can be integrated with 5G system. Now, this basically talks about if we have just 5G RAN and we don't want this, we don't have other things. So how will it look like? So you may have, say, a base station with PHY and MAC function. You may have adaptation function, which essentially consists of RLC layer. So the bottom, half, the lowest layers are basically data planes. So you may have optimization, which consists of PDCP and SDAF functionality, and interworking, which is GTP, UDP, and IP layers, and so on. And then the RRC, which essentially is responsible for talking to the UE, is actually a part of the SDN middleware. It also controls the radio resources. Therefore, the VBS, which is the virtual base station entity, is sitting on top of this RRC layer. So that is how we visualize this will look like. And then the unified multi-rat SDN controller is more or less an abstract view of resources, almost a rat agnostic view, and that is sitting on top of these virtual entities. And it has an interface to talk to the core, and that is for the control plane communication. And RAN is completely abstracted by this SDN middleware. So, and this is where, when you have this RRC layer sitting here, you can create multiple virtual base stations over a single base station. So let us say you have a cell, and RRC controls that cell, but that cell can be divided into multiple virtual cells, as part of these different VBS, and they can be put in different network slices. So I may have a cell which is at the radio level, there is a single cell, but at the controller level and at the other entities level, these can be divided into multiple virtual base stations or virtual cells on top of this RRC layer, and then they can be put in different network slices. So that is what I was trying to say earlier, that this allows for a much better abstraction, which can be used for network slicing features in a better way as compared to the existing 5G system. Now, here, it has been shown that okay, so I'll skip this because we don't have much time. So you can, obviously the slides are available, so you can read them. Now, this here, we have just put, WLAN AP and DNVCU CP, both of them. So that's again we have discussed in a way. Now I'll touch upon the 2061, so Frugal 5G network. So the Frugal 5G network, or 2061, actually came from the idea that we need to provide the radio connectivity to affordable radio connectivity or broadband radio connectivity to rural areas. So looking at, if you look at the connectivity data, you will find that most of the a large percentage of globally unconnected people live in rural areas. But we realize that there are a lot of fundamental reasons why we have this problem, and unless we address those reasons, or unless we look at those key characteristics of rural areas, it may not be able to solve the problem of rural broadband connectivity. So some of the reasons that we saw is that the rural areas are typically sparsely populated. They are not really dense areas. So you may have small population clusters, and then these clusters may be separated by vast spaces. So some of the figures here shown from India and Africa, you can see these circles are actually habited areas, and the rest of the areas are empty spaces. Now, it is not easy to put infrastructure in this, because it becomes much more costly to reach to these small circles of population or habited clusters. So, the deployment cost increases. We also know that typically the rural areas have lower income. So it becomes, the low average revenue per user is a reality there. And it becomes, it exacerbates this problem, because first of all, the cost of deployment is higher, and then the people have lower paying capacity. So it becomes a bigger problem. And then you have, challenges of manageability. You may not have available trained manpower in many of the remote locations and so on. So it is not easy to manage the networks, especially the cellular network and so on. So, some of these aspects were looked at by 2061 to arrive at an architecture. And so essentially it came up with the key requirements where the rural broadband connectivity needs to look at. Rethinking, we called it rethinking 5G requirements for. So affordability is one of the key aspects. We thought that mobility is not an important feature. Most of the users are not really mobile. You need a large coverage area support to cover, areas with small pockets of population. Connectivity to sparsely populated areas, as far as possible, energy efficient solutions so that it can keep the cost low. And also an important feature was localized communication. So people in the villages, they may like to talk to each other, and you don't really need to go to core network for enabling this localized communication. They also, in some cases, we figured out that they wanted some local content available to them, so that it is available even if the network connectivity to core or internet is not available. They can access this local content and local storage. So these are some of the things that actually played an important role in the definition of 2061. Now, as I said, 2061 doesn't have a goal of defining a new radio access technologies. It tries to just utilize the existing radio access technologies and integrate them in a fashion which is affordable and which can be used in rural areas. So basically, it has three components as far as the wireless or access link is concerned. You have small cells, which are typically supported through WLAN APs, and these are high-speed WLAN APs. It can provide high-speed connectivity to people in villages, within the villages, living within the villages. And then these Wi-Fi access points are connected through a wireless mid-haul or middle mile to a fiber point of presence. So if you look at India, you might be knowing about a BharatNet project, where fiber is being extended to Gram Panchayats. So every Gram Panchayat has an office, and the fiber is going there. no, though in future the plan is to take the fiber to all the villages, but right now I think they are going up to all the gram panchayat offices. Now every gram panchayat may consist of multiple small villages, and these villages may not have fiber point of presence. So the fiber point of presence is ending at the gram panchayat office. So that is where the optical fiber is there, and beyond that, you need connectivity to these individual villages. So that is being provided through this wireless middle mile. So we have identified certain technologies which can be used for this, and that is where the standard actually identifies and highlights some of their strengths and weaknesses as part of these technologies, which ones can be used. So I'll skip this. So this is over, and then at the end, I mean, there is one more important aspect of this, that you may have a large macro cell also, which supplements these Wi-Fi access points. And this large macro cell provides basic connectivity to areas around the villages where Wi-Fi access points are not there. So as I shown earlier, that if you look at this kind of population distribution on the left hand side, you find that there are small village clusters, but and then there are empty open spaces. But you would not like all these empty open spaces to be totally unconnected. So in order to provide some basic connectivity around these population clusters, outside outside these villages, you have a large macro cell, and it can be utilized, built using the LMLC kind of technology, which has been developed by the Indian IIT Madras and IIT Hyderabad and CEBIT and these organizations, which are now part of the 5G system. So the LMLC can provide a large umbrella coverage, and then you can have Wi-Fi access points within the villages, which will provide very high speed connectivity. So that's it. But so this is a list of the wireless middle mile technologies. I'll just quickly now wrap up. It's already, but the key points that has been discussed, which may have a bearing for the next generation, apart from the rural connectivity, is that decoupling of core from RAN and direct connectivity from RAN to internet bypassing the core. So those two things, which I discussed earlier, has been proposed in 2061. So what you want is that you have a village, so you may just like to connect to local servers and you don't really want to go to core, or you may go to internet without going to the core, because you don't really need core for, because most of the users, as I said, are not really mobile. So you don't really have to go to the core for those users, and you can provide direct internet connectivity from radio access network here itself. So if you look at this figure, so there is this edge component where the middle mile AP comes. So you can, from here, you can directly go to internet without going to the core. So that is what the idea is, and that is what is provided here. Now I will skip this, but I will show this slide where it actually builds this mechanism to decouple UE's communication with RAN from its communication with core. So core becomes an overlay network, and UE need not talk to core at all for connecting to internet or for connecting to data network, for connecting to local storage. It can completely skip the connectivity to the core, which is what has been provided in the 2061. So it sort of builds on top of 1930.1. It essentially utilizes the 1930.1 architecture, but on top of it, it enables this decoupling of core from RAN. So this also allows for any core to be used with any RAN, and you can it also allows for direct connectivity to internet bypassing the core, which we think obviously has an application in rural scenarios, but it also has may have an application in future mobile networks, the 6G system. So that is about it. And so here we have shown a figure, the advantages of what this may be is that you have a UE connecting to a macro base station, which we discussed that there may be a macro base station, LMLC kind of base station, providing a large coverage area, coverage in a large area. And the UE may be connected to that LMLC base station, but UE need not go to the core to connect to internet. So from the LMLC base station, it can directly go to internet bypassing the core. So that is what has been shown here, which is not possible in the 5G system. So if you are using 5G NR based radio, you will necessarily go to the core and you cannot really bypass it, which is what has been enabled in 2061. So here the RAN can work in a standalone manner, and that is what has been there. Now, advantages of this is that you can have features like NSA implemented in a much easier way. So if you decoupled core from RAN, so the 5G GNB can talk to 4G core without really going through the LTE node B, which is the case in NSA deployment today. So that's the other advantage of this. And so just to now coming to the last slide. So this is the summary. So it actually, if you look at this 1930 and 2061, so it proposes, I have highlighted the points of both. They have, 1930 dot proposes a disaggregated multi-RAN with a modular and reusable network functions, scalable architecture, separation of control plane and data plane. It also supports virtualization of RAN resources through SDN middleware, where an abstract information model of RAN data plane has been provided through this SDN middleware to the controller, and then it can be used for different features like slicing and so on. And then you have a unified multi-rat RAN where you can have a better performance, improved performance, and you can also have simpler implementation of features like dual connectivity. And then 2061 proposes a decoupled RAN and core. You can have a flexible architecture, interworking of any RAN with any core. And you can support features like captive network much easier. And then you can also bypass RAN through internet. Now, this is a future work. I mean, you can, there are some additional work that can be done as part of the next 30.2, 30.1 has been approved, 30.2 but we have not yet decided whether we want to do it as part of IEEE or we may like to do it somewhere else and so on. So that's why the further work has not been initiated as, but yes, it will be done hopefully soon. And these are some of the aspects, how to integrate with 5GS, the things that we discussed earlier, but there are some, as I said, there are some aspects which needs to be discussed, like impact on the UE and so on. And then that's it. So thank you very much. Yeah, I'm sorry I had to rush a bit to keep the time, but yeah, so thank you. Now I'll be happy to answer any questions.
Thank you, sir, for such a wonderful tech talk. I'm Mahesh here, so I'll just take 1-2 questions here, which has been put into chat box.
Sure.
Yeah, so first one is that, first question is how the simulations of these standards are carried out to find out their results. Are there any simulation tool available for 6G networks?
Okay, so these are, I mean, the simulations that we have done as part of some work in IIT Bombay and some of work we did. So those were done using MATLAB and NS3, but not a completely new simulator for the 6G system. But yeah, so whatever simulations were done using MATLAB, and we built some MATLAB-based simulation and NS3 also. But at the same time, I would say that simulations are being built all across, and we are also building a new simulator. And I believe Civit also has a simulator. I'm not sure whether it can be used for the 6G simulations at this today or not. But at IIT Bombay, we are developing a simulator which we hope will be useful for the 6G system. So that is what. But right now, we have just initiated it a few months back, and it is in early stage of development.
Okay.
Okay.
Yeah. Next one is it really possible to not use any function of core for local communication?
Yes.
Or
Yeah. Sorry.
yeah. And second part of question is, or we need to bring out some function out of core and place near to RAN for such use cases.
Yeah. So as I said, yes, some functionality. Actually, one of the things have been shown here in one of the slides, I believe. But some functionality you need because you need authentication, you need security, so you need some inputs for security. If you have so all these are coming from core today. But if you want to bypass core, then you need to have some of these functions as part of the RAN as well. So I think I mentioned it also that authentication, for example. So you can actually have some authentication built in as part of access network, as part of edge network elements, as has been proposed in 2061. And you can use that when you want to provide the service. So the question is absolutely, it's absolutely right to say that you can't, the way whatever core does today, you can't really skip everything. You will have to bring some of the functionality to RAN, but yeah, that's about it. What we essentially want is that we don't want to core to take the data to core when the communication can be enabled locally. So that's an important thing that we want to highlight here. And that is very much possible. You can completely skip core for the data path or data communication in case of localized communication.
Okay. Yeah. Next question we have: how SATCOM or NTN deployments will benefit from these standards?
Okay, that's a very good question. I am not sure how it will benefit, but it can be integrated in this framework. That is what we can say. And there is no problem in integrating in NTN network in this 2061. In fact, 2061 suggests the usage of NTN as one of the middle mile technologies. And so it actually can be integrated within this. We don't see any issues there. And yeah, so that is what I would like to say.
Okay. Next one is how through edge we can get connected without using core. That is, as edge is used to storage and as server.
Yeah, so as I said, yes, edge can be used for storage also. You can have storage servers containing some additional data functionality. You can have content placed there, and those can be used to serve the users in that. Say, so for example, if I go to this figure here, just a minute. Yes, so if you look at this, so this tower which has been shown here, you can think of this tower as being placed in a Gram Panchayat office, and there may be some storage servers also there. The tower provides macro connectivity, and there also provides the middle mile connectivity to the Wi-Fi access points in small villages which are far away from that. And any data which is coming from, say, this edge, and all of them are located in one place. So this edge element has servers, the macro base stations, and the middle mile base stations. And any data which is coming from these storage servers can be delivered to the users in the villages. And you don't really need a core to serve that. So it's not really necessary to use core with this architecture.
Okay. in continuation of same question, is there any particular 6G architecture or still it is to be finalized?
Yeah, there is nothing today. ITU, I believe, and India would know much better. ITU is just discussing vision and high-level requirements and so on at this stage. So there is nothing like a 6G architecture in place today, but obviously there are research groups and there are people working on the aspects of the 6G system and how it will look like and so on. So, but it is in evolution right now and nothing final.
Okay, just last question now.
Yeah, please.
Could you please enlighten about security aspects in 6G network? Does this standard cover security features or any other standard covering more of security in 6G?
Okay, so I think, as I said, 6G is not yet here. So security in 6G will be discussed in the coming years. So that is as far as the 6G security is concerned. I don't think security in 6G is yet finalized or anything like that. And as far as these two standards are concerned, they were not really focused on security aspects. They were primarily focused on architecture, how to bring the network elements together, and so on. Security can be done as part of further evolution of these standards, but they are not really focused on security aspects.
Okay. Thank you, sir, for answering all the questions very
Uh,
precisely.
Hello,
Yeah.
sir. Excuse me.
Yes, yes,
Sir, one more question, sir.
yes,
Now,
please.
if I want to study about the security of 6G, can I consider it to be the extension of the 5G security challenges, sir?
Yes, sure. I'm not a security expert, so I'm not really the right person to answer this question. But I believe, as a general guideline, the 5G security will definitely have some, bearing on how the security for 6G system is designed. So that way you can definitely look at the problems of 5G security and see how you can circumvent them in 6G system. But yes, I mean, as I said, I'm not a security expert, so you should take it with a pinch of salt.
Thank you, sir.
Yeah. So thank you, sir, for answering
Thank
all the
you.
questions very patiently. And I request participants to reach out if any question you have to
Yes,
mail
yes,
ID
yeah. So
given
you
there.
can, yes, yes. So my email is here, so you can
Yeah.
contact me over my email.
Now I request Chair ComSoc Bangalore Chapter to conclude the session.
Thank you, Pranav, for this very engrossing session. I think I kind of found the questions were really probing. I think I would like to at least compliment the audience. I think this is not a very easy topic also to comprehend, and a lot of the audience stayed back and listened patiently. And I believe the audience would have benefited from the interesting insights which Pranav has tried to bring forth. So Pranav, I thank you for that, and thank you for your time. On behalf of IEEE ComSoc Bangalore, I want to extend a vote of thanks to you. And I think we'll reach out to you again for any other 6G specialized topics. And
Sure.
thanks a lot for your time, and thanks a lot to everyone else for showing up. I see that the number of participants has dwindled a little bit, but I think that is okay. I think, but nevertheless, it was a good. I see one hand raised. Is there still a question, Vijaya Lakshmi, or is the question already asked?
Sorry, sir. It's already asked. Thank you.
Okay, okay. Thank you. I think with that, then we can conclude the session now. We are a little, I think we have overshot by 14 minutes. So thank you.
Yeah, okay. Thank you very much. So thank you for giving me this opportunity. Thank you all. Yeah.
Thank you all. Thanks a lot.
Okay.
And we
So
will
should
close.
I close the session now? Leave the
No,
meeting?
I will do that. That is okay.
Oh, okay, okay. Okay,
Thank you.
okay.
Yeah, I think you can log off if you want. Thank you.
Okay. Okay. Thanks a
Thanks a
lot.
lot.
Thank you.
Thanks, everyone, and we'll talk again with the next talk. Thank you. Bye.
Thank you, sir.